Well, good morning, ladies and gentlemen. I've been watching quite a few people out there that seemed to be a little bit confused about the electrics within these Yamaha Enduros. The one exception in the early models was the AT, which has battery ignition, but pretty much most of the rest of them are magneto ignition. And trying to follow these lines out, Yamaha does a pretty good job of using the same color across the line of motorcycles for certain things, like pink is the horn, and brown is switched power, and red is, of course, battery power. And then there's brown and green, which are left and right turn signal colors. So let's take a look at what we've got here and see if we can't, maybe, I don't know, maybe I'm not that good an explainer, but maybe we can just take a little mystery out of it. So let's take a look at this little drawing I have. Okay, here it is. Let me see if I can get the camera to cover the whole thing. All right, it's all there. And we have a stator here. We got a battery over here. We got a rectifier up here. We got a main switch. And we got an ignition coil here. So let's see what happens here. I'm going to see if I can hold this and walk and chew gum at the same time. So we're looking here at the stator, and this DT250 is what I'm working on here. It has 2 coils on the stator. The thing is that one of these coils actually has 3 secondary windings, or 3 taps on the secondary winding for different things. Now, as the flywheel, which has magnets in it, spins around this thing, those magnets induce EMF, electromotive force, voltage, into these coils, both the source coil and the utility coil, I guess I'd call it. So these 3 wires coming off here represent different voltages that go up to the main switch, and from there are put to different places to accomplish what it was the engineers wanted to accomplish. So let's take a little look. The first one off of there is a green. And that green goes up to the switch, and in the switch, that green is, where does it go? That green goes over here to the white, and that's on the rectifier. So this green makes this connection here, and it goes up to the rectifier. This is a schematic symbol for a rectifier, this being the positive side, this being the negative side. So this AC voltage coming off of this coil down here goes up on the green, makes a connection to the white through the switch, and goes to the positive side of the rectifier. Now that only lets positive pulses from the AC voltage coming off the coil through. So you get positive pulses coming through, and they go out on the red. Now the red also goes over here to the fuse and down to your battery. So this is basically charging your battery. But these lines are all tied together, so that same 6 volts in this case comes over here to the red, and when you put the switch in position number 1, that red is tied to brown right here. So that becomes your switched voltage from the battery. So that's should be a good steady 6.4 or somewhere in that area, if your battery's good. All right, where does the brown go? Well, the brown goes to several things that you need all the time, whether you have the lights on or not. And that means the horn, the turn signals, and the brake lights. Now, in the case of the horn, the brown is sent directly to the horn button, one side of the horn button, and the other side of that horn button is tied directly to ground through the handlebar. So when you push that button, it draws current through the horn button and hence through the horn and makes the horn beep. Okay, in other words, it provides a ground to the horn. All right. The other thing that happens, you got brake lights. You have to have brake lights all the time. So in this case, that brake light has one side tied to ground. So when you operate either your front brake on the handlebar or your rear brake on the foot peg, what you're doing is you're allowing the battery voltage to go through and to the actual brake light. So in this case, you've already got a ground on there and you're switching the power to it. Okay. The turn signals, the brown goes to one side of a 2-pin flasher, and when you turn on the light, it draws current through the flasher, and the flasher has a little lever in there that heats up and then breaks away. And it goes back when it cools, and it heats up and goes away. So this little lever, so to speak, will just keep doing that as long as there's a path through the lights to ground for the power. What else do we have? All right, let's look at green with a red stripe here. Green with a red stripe is just a high-powered version of green. It goes to all the same places, and you do this at night. When you put your switch in switch 3, it switches from the green to the green-red. Okay, next, yellow. Yellow, what is yellow? I know what yellow is. Yellow is a straight AC voltage. It's coming off of this lead here, and it's alternating current. It's not DC. And when you switch on, put the switch in position number 3, switches that AC voltage to a couple of things. First, to the headlight switch for the high and low beams. You'll select which one you want it to go to with your switch. Then to the meter lights, so that you can see the meters at night, the speedometer and the tachometer. And it also lights up the indicator light for the high beams when you're in high. So that pretty much covers the supply coil here. Let's take a look now at the source coil. Now, a lot of people think if you have a dead battery, your bike won't start, but that's not true. You don't need a battery at all to make this bike start. You've got a source coil here, and with that flywheel flying around the outside with those magnets in it. It induces a voltage into this coil, which is connected to a capacitor or a condenser, whatever you want to call it. It's also connected to the kill switch, and it's connected to the ignition coil. And once again, it's connected up to the main switch. All right, let's see where all those things end up. In the main switch, when you turn this main switch to position 1, which is off, it ties this lead to ground. Now, if you're out running around and you drop your bike or something and you want to shut the engine off quick, you hit the kill switch. That does the same thing. It puts a ground right here. With a ground right there, you'll never get any spark. So, when you turn the key on, you take the ground off here. If your kill switch is not grounding you out, and the flywheel goes around and round, when you hit your kick lever, you'll generate a voltage here. And that voltage will, if the points are closed, which they are most of the time, by the way, that will be going up to the ignition coil primary lead. All right. The primary lead is, I think it's about 150 to 1 over the secondary lead. So you're basically, it provides a voltage that gets multiplied by the coil that goes up to here. So there's a ground here, so you got the primary lead going through here to ground, and you got this lead up here going through here, and it's tied to ground here on the spark plug. So when you open up these points, which is what happens when this cam comes around and pushes this up. It's not a very good representation, but the cam comes around and it pushes these points apart. That opens up the circuit, and so you can't provide any more voltage to the primary. What happens is you've had a voltage run through here, building up a big field around the secondary here. As soon as you open up these points, you get no more here, and this field collapses. And when it collapses, it sends a whole bunch of voltage, about 15,000 volts, I think, up to the spark plug. And that jumps across the gap and then ignites your gas, and away you go. Now there's some other things. I don't know for sure. I think let you know that the turn signals, I've covered that in other things, but the turn signals use green and brown wires. I can never remember which side is green and which is brown, but you'll know when you open them up and see, unless somebody's torn them all out. But it's in the book. So that's the way your electrics work, at least on this DT250, and a lot of the DT2s, DT3s, CTs 1, 2, 3. But the AT is a little bit different, because the AT uses battery ignition. So if you don't have a battery with the AT, which is a 12 volt, your machine won't run. You have to have a good battery. And that's the lesson for today. Well, folks, I hope I did a good enough job of explaining that, so it may help one or two people. I'm suspecting that a lot of you knew all that stuff already, but I don't know. There's a lot of questions about it, and people start swapping out parts, and in most cases you don't have to. So, like I said, I hope this helps somebody. And if you enjoyed this, please give me a like and maybe hit the subscribe button and the little bell. That would help me a whole lot too. And I'll try and do some more things like this. Maybe I'll do one on the AT next.